Hi, today we're solving problem number 36. In this problem, we're given the decimal number 585, which is this long number in binary, and it's a palindrome in both bases. So here we have 585, and here we have a palindrome up to here, and then the same thing is repeated on the other side. Find the sum of all numbers less than 1 million, which are palindromic in base 10 and base 2. So this problem is actually a really simple one-liner. So I'm going to go over and switch over to IntelliJ. I'm going to create a val all that work. This is going to be, we're going to start from 1 and go until 1 million. So yep, we want to go less than 1 million, so we don't include that. And we're going to filter. If we're given number n, we want such that n itself is a palindrome in base 10, so we can do n.toString is equal to n.toString in reverse, and I can do this on the next line. We want to check that n in binary is also a palindrome, and there's a really easy way to do that. With Scala's rich int, there's actually a method toBinaryString, and toBinaryString takes your number and gives you the binary representation of that number as a string. So now to check if it's a palindrome in binary, I just do the same thing I did with n.toString, n.toString.reverse, but I do binary string instead of string. Now I print on all that work. And I can run. And we can see the list. But what we want for our answer is the sum of all these numbers. So we run that. So that gives us our answer, but can we do better? And for this solution, we can. One thing you'll notice is that we're calling this toString twice and binary string twice. And we don't need to do that. We only need to calculate the string in base 10 and the string in base 2 once each. So what I'm going to do is I'm going to turn this into a multi-line filter. What I want to do is first I want to check that it's a palindrome in base 10, and then check if it's a palindrome in base 2. But I don't want to check if it's a palindrome in base 2 if it's not even a palindrome in base 10. So right now, with this AND function, it'll actually check this first, and only if this is true, then it'll check this. But if we were to pre-calculate the toString and binary string, then we would be calculating binary string unnecessarily in the cases that n itself is not a palindrome. So what we're going to do to fix that is we're going to create two blocks, and we're going to use AND for each of these. What I'm going to do in the first block is calculate numString is going to be n.toString, and it's going to check if numString equals to numString.reverse. So here we can see now we're only calculating toString once. And by doing this block, the second block won't even be evaluated if the first block returns false. But in the case that the first block gives us true, we want to do val binary string equals to n.toBinaryString, and then check if binary string is equal to binary string.reverse. So now we're not calculating anything extra or anything repeatedly. And now we can run, and we get our answer. So that's it for problem number 36. I'll see you next time when we solve problem 37.